Hello students, today we are going to discuss the new Cartesian sign convention for spherical lenses. Then we'll solve the numerical on the convex lens and the concave lens, and also we'll discuss power of a lens. Now the new Cartesian sign convention for measuring various distances and height in case of lenses are similar to that of the spherical mirror, but only difference is there that the distance in the spherical mirror is measured from the pole, but in this case we will be measuring the distance from our optical center. This is optical center of the lens, so the distance is measured from the optical center. Now object is always placed to the left, always is placed to the left of the lens. This implies that the light from the object falls on the mirror from the left side. So this is the direction of incident light, it is falling from the left side. Okay. Now all distance parallel to the principal axis are measured from the optical center of the lens. All distance are measured from optical center of the lens. The object distance will measure from here, and if the image is from here, the distance will be measured from the optical center. All the distance measured to the right of the origin, that is right of the optical center, will be considered as positive. So distance along incident light, that is from this side, that is on the right side, it will be considered as positive and taken as positive, and if the distance measured from to the left side is taken as negative. Distance measured perpendicular to and above, this above, that is the height, if we take it is upward, then it will be taken as positive, and the distance measured perpendicular to and below, if the height is below the principal axis, then it will be considered as negative. These are the sign conventions that we'll be using in the numericals for solving the concave and convex lens. Now let us see the formula for the lens and also for magnification. Now what is U? U is object distance measured from the optical center. V is image distance, F is focal length. So the lens formula is 1 upon F is equals to 1 upon V minus 1 upon U. And also magnification, that we know that it is the ratio of height of the object, height of the image to the height of the object, denoted by M, that is equals to H dash upon H. Also the magnification produced by the lens is also given by the formula V upon U. Now let us solve some numerical based on the lens formula. An object 5 cm in length is held 25 cm away from a converging lens of focal length 10 cm. Draw the ray diagram and find the position, size and nature of the image formed. So I am drawing a diagram here. In this question it is given that the focal length is 10 cm. So since this is the principal focus in the right hand side, so right hand side it will be positive. So focal length is plus 10 cm and the object is placed at a 25 cm. So that means it will be placed on the left hand side, so it is minus 25 cm. Size of the object is 5 cm. Now I am drawing a rough diagram of the convex lens here. The object is placed at 25 cm. That means this is 10, 20 and this 25 cm here. And it will be parallel to the principal axis. Will pass through focus. And another ray which is going towards optical center. And it will meet somewhere between optical center and so it will meet between F2 and 2F2. So this is the ray diagram for this question. Now in the if you see that it is forming between, the image is forming between f2 and 2f2. That means the image will be formed between 10 to 20 centimeter. That we'll see when we'll solve it. Now the length formula is 1 upon f is equals to 1 upon v minus 1 upon u. So we'll put the value 1 upon 10 is equals to 1 upon v minus of minus 25. So this will become positive. So 1 upon 10 is equals to 1 upon v plus 1 upon 25. So 1 upon v will be equals to 1 upon 10 minus 1 upon 25. Let us solve this. This will LCM will be 50 is equals to 1 upon v. Now 5 and here 2. So it is 3 upon 50, that is equals to 1 upon v. So v is equals to 50 upon 3. When we will solve it, it becomes 16.666. So it is round off, it will be 16.67 centimeter. As I told you, the image will be formed between 10 to 20 centimeter. So this is correct, 16.67. And since the image is formed on the right hand side, so the value of v will, that is the image distance, will be positive, that we have got. Now we have to find the height of the image. We know the formula h dash upon h is equals to minus v upon u, not minus, v upon u. So h dash, this is the ratio of the height of the object, height of the image to the height of the object, and the formula is v upon u. Now h dash we have to find. H is given in the question 5 centimeter is equals to v. V will take as 50 upon 3 upon u. U is minus 25 centimeter. So now let us solve this. H dash is equals to 50 upon 3 into, it will be reciprocal, minus 1 upon 25 into, cross multiply this, that's why it will become 5. So this will cancel 5. This will cancel 10. So minus 10 upon 3. So h dash is equals to minus 3.33 centimeter. So minus sign is indicating that the image is inverted image. So nature of image will be real and inverted. Real and inverted. So in this question, the position of image is 16.67 centimeter on the other side of the lens, and the height of the image is 3.33 centimeter, and which is inverted. Minus sign shows in inverted image. So nature of image is real and inverted. Now let us solve another numerical on the concave lens. A concave lens of focal length 15 cm forms an image 10 cm from the lens. How far is the object from the lens? In this question it is given that the focal length of concave lens is 15 cm. As we know, the focal length of the concave lens, that is the focus, principal focus, is on the left hand side. So the focal length will be negative. So that means f is equals to minus 15 cm. And the image is also formed on the left hand side, so it will also be negative. So it is 10 centimeter from the lens, so v will be equals to minus 10 centimeter. Now we have to find how far is the object from the lens. So let us see. We'll use the formula 1 upon f is equals to 1 upon v minus 1 upon u. This is the lens formula. So 1 upon f is minus 15. 1 upon v, it is minus 10 minus 1 upon u. So it is minus 1 upon 15 is equals to minus 1 upon 10 minus 1 upon u. We'll shift the side. 1 upon u is equals to 1 upon 15 minus 1 upon 10. I have transposed minus 1 upon 15 that side. So 1 upon u is equals to, we'll solve it. LCM will be 30. That will 2 minus 3. So 1 upon u is equals to minus 1 upon 30. So u is equals to minus 30 centimeter. So it is, we have calculated the position of the object is 30 centimeter in front of the lens. So let us put the value here to draw the diagram. This is an object, this is 15 and 15, 30. So we have kept the object at 2f1. Now the ray of light will be parallel to the principal axis. And this is a diverging lens, it will diverge from the focus, will produce this from focus. So it will diverge this side. This is the incident ray and this is refracted ray. And the other ray of light will pass through optical center without any deviation. It will pass through optical center. So the image is formed between this place. So you can see the image is 10 centimeter. So 10 centimeter from this side. So this is negative. Object distance is also negative. And principal, this is principal focus. This is all negative. So U, V and F are negative in the concave lens according to the new Cartesian sign convention for spherical lenses. So the image will, the object should be placed at 30 centimeter on the left side of the concave lens. Now let us discuss about the power of a lens. You might have heard sometimes when you ask someone that what is the power of your lens, so they say that is minus 2.5, minus 1.5 or plus 1.5. Now this negative and positive sign will discuss how it comes, and let us first discuss what is power of a lens. Now power of a lens is defined as the reciprocal of its focal length. That means P is equals to 1 upon F. This is the formula for power of a lens. P is equals to 1 upon F, and this F should be in meter. When we are taking the finding the power of the lens, then the focal length should be in meter. Now the SI unit of power of the lens is diopter. And what is 1 diopter? 1 diopter is the power of a lens whose focal length is 1 meter. So I have written here 1 diopter. Diopter is the power of a lens whose focal length is 1 meter. Now as we know that the focal length of the convex lens is positive. That's why the power of a convex lens will be positive. Power of convex lens is positive. Whereas the concave lens, its focal length is negative because it is on the left hand side. So it is the focal length is negative. So the power of concave lens will be negative. Power of concave lens is negative. Now let us solve some numerical based on power of lens. Now let us do the numerical based on the power of a lens. Find the focal length of a lens of power minus 2.0 diopter. What type of lens is this? We know the formula for power. Power is equals to 1 upon F, and this F should be in meter. Now it is given in the question the power is minus 2 diopter. Minus 2 is equals to 1 upon F. So F is equals to minus 1 upon 2 is this in meter. So F is equals to minus 0.5 meter. If we convert in decimal, in centimeter, it will become minus 0.5 into 100 centimeter. That is equals to minus 50 centimeter. Since the focal length is incoming negative, that is minus 50 centimeter, therefore this is a which lens? This is a concave lens. Concave lens, the focal length is negative. So the type of lens is concave lens, or it is also known as diverging lens. So the focal length of a lens of a power minus 2 diopter is minus 50 centimeter, and it is a concave lens. Now let us solve the second question based on the power of lens. A doctor has prescribed a corrective lens of power plus 1.5 diopter. Find the focal length of the lens. Is this prescribed lens diverging or converging? Now let us see what is given in the question. Power is given plus 1.5 diopter and we have to find the focal length. We know the formula for power. Power is equals to 1 upon F. This is 1.5 is equals to 1 upon F. This F is in meter. So F will be equals to 1 upon 1.5 meter. So F is equals to, we'll remove this sign, make it 10 upon 15 meter. So we'll cancel this. This is 2 upon 3 meter. So F is equals to 2 upon 3 meter. Let us convert into decimal. This is centimeter. That is 100 centimeter. So 200 upon 3, and that is equals to 66.666. So it is 66.67 centimeter. So as you can see, the focal length is positive, and we know that the focal length of a convex lens is positive. Convex lens means converging lens. So the prescribed lens is converging, or you can say convex lens, because the focal length of a convex lens is positive.